Hello and welcome to our webinar, Hybrid Connector Series, Cabling Options and Application Examples. Thank you very much for joining us at this point. My name is Philipp Bertling. I am from the Department Product Management I/O, based in our headquarters in Germany, Fair, and responsible for the I/O accessories, which also includes the cables and connectors. Please share your questions with us. You can use the GoToWebinar question window for this. We will try to answer all questions at the end of the webinar. I'm turning my camera off again now, so you can have a view to the full slides. We have structured the webinar into 4 short points. We start with our ID from the system without control cabinet. Then I introduce you to our hybrid connector. After this, I explain some customer use cases, and finally, I will present you how to find further product information. I would like to start with our vision from the system without control cabinet. What you can see here is the example plant with different processing stations, a laser cabinet, a robot part, and a drilling part with an underlying conveyor belt. And what you see here is a conventional system with a very large central control cabinet. Very long cable distances in thick bundles, because every sensor and all power and motor cables are routed into the central control cabinet. Here you can see the next step that many customers have already taken. The space required by the central control cabinet is now only the half. The robust IP65-67 Ethercat boxes are mounted direct on the machine bed near the sensors, so they can collect the data via short sensor cables direct in the field. A part of the automation is installed in a decentralized control cabinet, a smart one, and the OCT, one cable technology cables, known from the drives, are also hybrid cables because they have feedback and break pairs with the power wires under one cable outer jacket. Here the OCT cables marked in orange. And the modules for direct I/O field installation provide the basis for simple plug-and-play solutions. The more efficient cabling minimizes the potential for errors. And this is a cabinetless system. EPP, Ethercat P boxes supplied by one cable with power and our high-speed Ethercat bus protocol collect the data in the field. The decentralized servo drive AMP 8000 integrates servo drive into servo motor is used here. The power electronics are therefore located in the system, in the field. The servo drives are supplied via a distribution module, and all is connected with our hybrid cables. So we have OCA, one cable automation for the entire field level. The one cable automation solutions can have a positive impact at almost every level and every device. For example, our AMP 8000 series supplied by one hybrid cable. So the communication and power supply through a single cable saves space, time and money, and the machine footprint is reduced. As you have now seen, is our hybrid connector an essential component of this cabinetless system. And I would now like to explain the hybrid connectors to you. So what's the hybrid connector? We have this little animation for you. This video shows how a hybrid connector is constructed. In this way, with the application illustration, the modularity of the system becomes clear. This example shows the size B17 with the possibility of 3, 4, or 5 power pins in addition to our trapezoidal data element. We have minimized the number of individual components. The colored imprints on the contact carrier show the wire colors and make sure that the pin assignment is correct. This is interesting for the connectors for field assembly. According to the Poka-Yoke principle, we reach and quick and intuitive installation. The metal sleeve with the additional clip provides complete shielding of the data element, the combination of power wires and crimping contacts, and it is all put together in the insulation body. And here you can see the two variants we have, the ECP and the ENP. I will explain the difference in a few minutes for you. So we have developed not only the connectors just shown in the video, we have developed a complete hybrid connector series with the sizes B17 up to B40 with different numbers of power pins from 2 up to 6 pins for your individual network and power consumption scenarios. But let's go through our so-called cable bunch step by step. So we have here our M8 and RJ45 standard connectors for Ethercat, the M8 A-coded variant for IP67 devices, and the RJ45 connector for IP20. And we have changed the round M8 connector into another shape, the trapezoidal shape, seen here, to have much space for additional power contacts. So it's the same function, but only another shape. This is a 2-in-1 solution, Ethercat plus additional power pins marked with a black cable and a yellow stripe. This is called ENP. And we have also bigger sizes from B17 over B23 up to the B40 connector, and all sizes include a uniform Cat5 enabled Ethercat element or Ethernet element, also called data or communication core. So the hybrid connector families are scalable from 24 volt up to 850 volt and 72 amps in our B40 connector. So now you know how Ethercat is integrated into our hybrid connectors. But we have also developed Ethercat P. Ethercat P is the basis of the one cable automation. So we combined 2 times 24 volts, each with 3 amps, with Ethercat in one cable and get Ethercat P. So the power coupled to the Ethercat data wires is Ethercat P. The P stands for power. So both cables have the same physics here, the yellow one and the black one with the red stripe. It's a standard Cat5 cable, only the color of the outer jacket is different. Yellow for Ethercat in this example and black with a red stripe for Ethercat P. And as you can see here, we can supply a device with a high-speed bus Ethercat and power with only one cable. So the additional power cable is eliminated. We don't have the sockets for power here on these devices. So we have also designed Ethercat P in the trapezoidal shape and therefore create the ECP variant as a counterpart to the ENP variant. ECP variant with red data core for Ethercat plus 2 times 24 volts with each with 3 amps is functionally the same as the M8 with the P coding connector, and the ENP variant with the yellow data core for Ethercat is functionally the same as the M8 connector with the A coding. So ENP is Ethernet based and therefore the universal variant. So it's not necessary to use Ethercat, but everything that uses a Cat5 cable is syncable with the ENP variant. So to prevent the ECP and the ENP connectors from being plugged into each other, they have a mechanical coding. This is a must-have requirement to protect the devices because power is on the data core of the ECP variant. So this is solved quite simply. The contacts of the data core are inverse. So here you see both pins in the ECP connector phase are the female variant and at the counterpart the male variant. In the ENP connector phase are the pins for the data as a male variant and the power pins are female. So a plugging is not possible mechanically. Yeah, and as you have probably already thought, we have also realized the entire hybrid connector family with the Ethercat P core. This is one cable automation, OCA, based on a single Ethercat P cable, integrates communication and power supply plus additional power pins in one hybrid connector. So this connector series is a Beckhoff development. The sizes are similar to the known designations M17, can therefore be compared with the size B17. We named them B because of the bayonet closure. Here you can see the integrated noses of the bayonet closure. And yeah, for example, the M8 P-coded can be used for intelligent sensors with higher power supply needed, like encoders or barcode scanners. The B12 connector size can be used for stepper motors with the controller, and the bigger sizes, B17, B23 or B40, can be used for example 230 volt asynchronous motors with a frequency converter. So the one cable technology opens new ways for modular machine concepts, as you have just seen in this example for the system without control cabinet a few slides before. So, and a size and the connector phase include not only the connecting cables, as you have seen in our cable bundles, but also the matching counterparts. This overview here exists for every size and every connector phase. So representative for the others is shown here the B17 connector with 5 power pins as an ECP variant. And we have in the middle the connecting cable, the plugs for field assembly here in the metal housing, the raw cable sold by meter, and yeah, protection caps for IP65 and 67 protection when the counterpart is not plugged in the machine. And you can choose from 6 different flange variants for each connector. So we have the both square flanges, then 2 flanges for rear assembly and 2 flanges for front assembly. In a short and in a long design each. Here we have the metal part housing is shifted inwards for the short variant. So it depending on where you have more space. Inside, then you have to use the short variant, or outside can use the long variant of the flange. Here you can see the wall from the control cabinet, for example. So if you have not understood something because I was too fast at one point or the other, then you have the possibility to watch the recording of this webinar again afterwards and skip to a relevant point. Okay, now we come to our customer use cases and start with this one, the system concept with B12 and a handheld. Here we have a system that produces plastic parts and several processing steps with finally packaging and labeling. The customer is based in the automotive industry. So we have on the right side the panel and an industrial PC and power supply in a small control cabinet. BOS is installed direct on the system, so on the machine bed. So that's our starting point for the B12 flange for reassembly, connected via the 3-meter long ENP cable to an handheld. So the customer built his own robust handhelds. The handheld works as a supplement to the panel. He gets information about the system or the operation with our HMI via BOS devices. So the user therefore has two options to control his system, with the handheld or optional with the panel mounted on the machine. So here the customer uses our flexible B12 cable with 2 additional power wires for the 24-volt supply. The handheld was once supplied with 2 separate cables. But however, the cables disturb too much. 1 cable is more handy than 2. Here's our next example. We have again a system from the automotive industry. Here you see a control cabinet with industrial PC and 2 power supplies at the left side. 1 power supply for 24 volt and 1 supply for 48 volts. So with the B17 flanges and the integrated 5 times 1.5 square millimeter power wires, the 2 times 48 volt are transferred over a distance of 30 meters into the field to the robust Ethercat boxes. So we have a very long distance of 30 meters here. The motors are attached to the robot arms here to move the gripper, the front of the robot arm. The gripper on the robot arms are used for handling and mounting of plastic parts. The customer uses our servo box EP72110034 to configure the motor parameters. He gets the needed fast and highly dynamic positioning tasks. So our servo motor Ethercat box with integrated OCT 1 cable technology offers the needed high servo performance for the integrated AM81 series motors with up to 4.5 amps each. In this slide, we show you 2 strands as an example. In reality, they will have in each application between 6 up to 15 of these strands. Here is the used flange. Here. So as you can see, we have the possibility to install the specific connectors needed for the device to the flange. In this case, the 7/8 inches connector for the power supply instead of the open power wires, and the M8A coded connector for Ethercat instead of the RJ45 connector. So the customer uses this modular system with our IP67 boxes to put power into the field over a very long distance with a lower voltage drop. So previously, the system was equipped with a 5-meter long control cabinet wall. This large central control cabinet was almost completely eliminated. So we have here only very small control cabinets. So our last customer example with B23 and B40 connectors. This is the example picture from our next customer project, fish farming. The customer has a hall with which there are different water basins, and the customer has calculated that its energy requirement for the pumps connected here is around about 41 kilowatts. So the customer came to us, and together we looked which connectors were suitable for his high power requirements. The variant highlighted here was chosen, the B40, with the 16 square millimeters power wires integrated and the long square flanges. For the lower power requirement in another area of this application, the B23 variant with 4 square millimeter power wires was chosen, also highlighted here. And here we have the system for the fish farming. So we have a terminal box with panel and main supply cable in a hall. In the hall there are different water basins, as you have already seen. At each water basin there are several pumps, shown here as a circuit symbol. And to transport the water to the filter system or to other basins. In addition, we have EPP boxes, so our Ethercat P boxes on each basin. With these, the status of the pump is controlled, start, stop, and an error message. Also temperatures, and with special sensors, the pH value of the water is measured. So it is notable that connectors for field assembly are here instead of the pre-assembled cables are used. So the background is that the customer sells this concept to several different end customers, and the water basins always have different distances. Therefore, he assembles the cables by himself in the field. So he buys the connectors for field assembly and the raw cable on a big wall. So in maximum operation, 41 kilowatt are required at the pools when all pumps are running in parallel. So at the calculation of the maximum power shows, we reach 48 kilowatts with the B40 plugs. Because the energy requirement of the upper basin here is lower, the size B23 is used instead of the B40 connectors. So due to the cross-section reduction from 16 square millimeter power wires on the B40 to the 4 square millimeter power wires on the B23, fuses must be installed at this point. And here the customer uses our two largest designs to transport a lot of power. The connectors are shown here are so very filigree, but here's a photo of the B40 connector. Here you can see how small the contacts of the data element are in comparison to the big power contacts, which transport here in this case 66 amps each. So here the customer flexibly uses different connector sizes and still has an uniform system. Okay, now you have just seen different possibilities and that we have a very wide range of products. That's why I just want to show you the way in which you can find wished product information. So we are on our new redesigned website and click on the category I/O, for example. Then we scroll down to the accessories panel and find the hybrid cables via the pre-assembled cables. I open any product page. In the documentation and downloads tab, under information media, there's the sheet with an overview of our hybrid cables. So in the front part, you can find a lot of general information. This is followed by the overviews of the different sizes that you have just seen in the presentation. Here's the ECP variant and the ENP. The matching crimp contacts for the field wireable connectors are listed here. And here further accessories like color coding rings for visual marking. So the data sheets are linked behind the product ordering information, and you can click to a rendering to get to the data sheet. Here's a cable parameters, dimensions and pin assignment, and at the end of this sheet, the ordering information. Another way to find the needed cable is to use the new filter options. We select the cable type and choose the variant for Ethercat. In addition, selected the desired wire cross-section of the power strands, as you will be taken to your selection. So, which then takes us to the product page, for example, for this extension cable. Okay, we have now reached the end of the webinar. You have learned about different ways in which customers are already using hybrid cables to make their systems more modular and modern. You have probably thought in between about how you can improve your system with the many options offered by our wide product portfolio. So let me resume the positive aspects of our one cable solutions at this point. As you can see in this illustration or overview, the hybrid connector series allows us to create a cleaner look in the system. The use of different sizes and combination of ECP and ENP cables gives us a very great flexibility. So the more compact design of systems, machines, and devices reduces space requirements. So the needed footprint is smaller, and we create a cleaner look in the system. More compact cabling means also smaller drag chains and cable ducts, and we need no more spatial separation between power and signal. So yeah, less complex cable feed-throughs are also possible because we only need one hole in the wall instead of two holes. The mass or the cable height is reduced. So therefore, for example, less rotating mass for moving parts such as drag chains, robots, and handling units. The reduced number of plug connections, which reduces the risk of failure and therefore system downtimes. We have a less and faster troubleshooting as there are far less sources of error. And we have a simplified and fast installation. Additional, we have UL approval for our pre-assembled cable variants, so for our complete assemblies. And take in your mind that less logistics are required. So less storage place is needed. Less component diversity also means less part numbers, booking operations, and therefore booking errors. So those were a lot of positive aspects about the Beckhoff hybrid cables you heard in this webinar. I'm sure there were some that could give you a significant edge in your application to make your end customer and you happy. So we are looking forward to growing together with you. That's it for the presentation. We will now turn our attention to your questions. I would like to thank you very much for watching. Wish you all the best and hope hearing from you soon. Thank you.